You know, when you think about powerful forces, you probably think of explosions or giant machines. But what if I told you that one of the most destructive forces in engineering comes from a tiny, imploding bubble? It sounds crazy, I know, but we're going to dive into this phenomenon called cavitation, and trust me, it's going to blow your mind. So, to get our heads around this, let me ask you something that sounds completely impossible. Can you boil water without using any heat? Like, at all? The answer, incredibly, is yes, you absolutely can. And that's our secret right there. It's a process called cavitation. You can think of it as cold boiling. Instead of cranking up the temperature, you're just dropping the pressure, fast. But here's the real kicker. Making these bubbles, totally harmless. The real danger, the raw power, is unleashed only when they collapse. All right, so how does this whole cold boiling thing actually start? Well, to see it in action, we need to look at places where water is moving really, really fast. Think of something like a ship's propeller or a turbine blade. Okay, so picture water flowing over a curved blade. The water that has to go over the top, curved part, has to travel a longer distance, so it speeds up. And here's a basic rule in fluid dynamics. The faster a fluid moves, the lower its pressure. If that water moves fast enough, the pressure can drop so low that the water just starts to boil right there, even if it's cold. And poof, you get these little pockets of vapor. These are our bubbles. Now, what's so wild about this is that the birth of this bubble is, well, it's gentle. It's quiet. Nothing dramatic. The true destructive power is hiding, just waiting for that bubble to collapse. And here we go, the main event, the collapse. The second that little bubble drifts away from that low pressure zone and back into an area of normal, higher pressure, it doesn't just pop. No, it implodes violently. So when this bubble collapses near a hard surface, it doesn't collapse perfectly. One side caves in faster than the other, creating this tiny, focused jet of water. And get this, it fires that jet at 2,000 meters per second. That is literally supersonic. That's not all. The implosion also creates an insane shockwave that hits with 8 gigapascals of pressure. To put that in perspective for you, that's like taking the pressure of 80,000 Earth atmospheres and focusing it on a microscopic point. It's more than enough to punch a hole in solid steel. And if you think that's extreme, it gets even crazier. For just a split second, as that bubble crushes itself, the vapor trapped inside is compressed so violently that its temperature shoots up to a staggering 5,000 Kelvin. Yeah, let that sink in for a moment. For a brief, infinitesimally small moment, that tiny spot in the water is hotter than the surface of the sun. It's just an incredible amount of energy being focused into a space smaller than a grain of sand. So what you end up with is this tiny microscopic arsenal. You've got these microjets that act like high-pressure water cutters, you've got shockwaves that are like tiny hammers, and this is happening thousands of times every second. The result? Solid metal gets blasted away, leaving it looking like a pitted, spongy mess. Okay, so this is obviously an incredibly destructive force, but like with many things in science, it begs the question, what if we could control it? What if we could turn this microscopic hammer from a weapon into a tool? And it turns out we can. It's really two faces of the same coin. On the one hand, when it's uncontrolled, cavitation absolutely shreds machinery. But when we harness it, we use that same physics for precision ultrasonic cleaning, scrubbing things at a microscopic level. And even more amazing, in medicine, doctors are using focused ultrasound to create cavitation and non-invasively destroy tumors. Just think about that. It's the exact same physical event, a bubble collapsing. The only thing that separates a weapon of destruction from a life-saving tool is our ability to understand and control it. It really makes you wonder, doesn't it? What other terrifying forces in nature are just out there, waiting for us to figure out how to harness them for good?